Hello, and welcome to our very first Team Teach lesson of the semester.
Today, you will learn algebraic reasoning, graphing, and connections with geometry. I'm Laura Wynn.
Crystal Lambert.
And I'm Kat Knight. By the end of today's lesson, you will have made a connection between equations and graphs.
For instance, have you ever wondered what it would look like if you graphed your elevator ride?
Well, if that crazy thought has ever popped into your head while you're sitting on the elevator forever, man, have I got the graph for you. So here we go in our, just kidding. Okay, here we go. In our graph, you can see that our very unlucky person in the elevator had to stop at every single floor on his way up. But for him, for us, it made a beautiful graph. So we're sorry, dude, if you had to pee, but for us, we got a good graph out of this. So on our x-axis, we have put our stops, and on our y-axis, we have put our height of the elevator.
How do I determine what to put on the x and y-axis?
Well, the x-axis is this one right here, the bottom, the horizontal, will always be the independent variable, meaning it'll stand by itself. So this one will always be the same no matter what. But this one is the dependent variable, the y-axis, and it depends on the stops. So basically, as you can see, when the elevator is stopped, it's at a straight line, meaning it depends on the elevator to be stopped to be if it's rising or staying in the same place. Laura, could you please show us a graph next to represent what it looked like to bounce a ball?
Of course. So if you have a bouncy ball and you drop it, the first bounce is always going to be the highest, followed by shorter bounces. In the graph, you can see the y-axis, or vertical axis, represents the height of the bouncy ball. The x-axis, or the horizontal axis, represents the number of bounces.
Why does the height of the bouncy ball change?
Well, when you first drop a bouncy ball, the initial bounce is the highest. As the number of bounces decrease, so does the height of the bouncy ball. Each bounce, if you notice, is shaped like a curve, which is also called a parabola. Crystal, what would it look like if we wanted to track our gas gauge?
Oh, I have the perfect graph for that. We're going to pretend, Laura, that we are all going to Mardi Gras.
Woohoo!
So, on our graph, the y-axis, which is on the left side of your screen, and it is vertical, which means it goes up and down. That's going to be our gas gauge. So that's going to tell us how much gas is in our car. And then on our horizontal axis, which is side to side, we have our x-axis, and that's going to show us how far we've been driving. So we get in our car and we start driving, and the further we drive, the less gas we have. Go figure. Anyway, so you can see we start like midway the graph because apparently we didn't fill up before we left and all our excitement. And then we drive, and then we start getting low, and we say, okay, we need to fill up.
Why does the graph go straight up?
Well, when our line goes straight up or vertical, it tells us that our car was stopped, right? Because the x-axis or our horizontal line is our distance. So when you stop to fill up with gas, you're not going anywhere. So only the amount of gas in our tank is going up because we're not going anywhere. You can't drive while you're filling up. That would be really, really bad. So you can tell that once we start driving, the further we drive, the less amount of gas that we have in our tank.
Okay, guys, so for our next holy macaroni cheese bologna, look at that. There's a lot of words and symbols, and oh my goodness gracious, how are we going to do this? Well, we are Smarticle Particles, and we are going to simplify this and make this a lot better. So here is how we are going to simplify our problem. So we are looking for this f of x equals this crazy thing right here that I'm not even going to try to say in words because it's just going to confuse you more. F of x, fun fact, is actually the function of x is what it means. But anyway, so we know based on our problem that what we're doing, f is just multiplying x by 3. We can do that. That's easy. And then g means we're adding 8. I got that. We can do that. So when we put this simple equation together, we get dun dun dun. There she is. Oh my gosh, that is so much easier. Does this look familiar? Well,
Yes.
it should, because it looks like, bam, there she is. We've seen this. We can do this, ladies. We got this, ladies and gents. Sorry. So for now, they gave us the coordinates in the problem, and we're going to plug those into this beautiful equation that we have written here in red. First number is 0. Plug in our math, there you go. Second number is 1, plug in our math, there you go. Next number, plug it in, there you go. Next number, plug it in, and there you go.
I don't know, Kat. This looks like there is an awful lot of steps. Is there any way we can organize this a little better?
Actually, there is a very easy way we can organize this. We can put this in a T-chart or a little graph, whichever one is best for you. I have put this in a little 2-column graph, and it will look something like this. Here on the left side, we have our x-coordinate, which is 0, 1, 2, and 3. And then on the other side, we have our y-coordinate, which is 8, 11, 14, and 17. And if you look, that's all the numbers that we got over here. These are coordinates, remember? So this is x, and this is y. Very easy to figure this out.
Hey, Kat, how exactly would you graph this problem?
Oh my goodness. Easy peasy lemon squeezy. We got this down. Let's see. Bam. There she is again. There's our table that we just made. And as I said before, this is an x-coordinate. This is a y-coordinate. Once we have those put together, we can easily put that on a graph because all we've got to do is, well, we know how much to move left to right, 0. So on this one, we go 0. How much do we move up and down? Well, that's our y-coordinate. That's 8. And then we move on to the next one. Here's 1. How much do we move up and down? Well, there it is right there, 11. So we move up 11. It is actually that simple. I'm not kidding you. It's that simple. And then if you look, you'll notice that all of these go up by 3. That's because y is a function of x, meaning that this is a linear equation.
All right, so this problem gives us 2 points or coordinates to graph our coordinate on our coordinate plane.
Laura, what are coordinates in a coordinate plane?
That's a very good question. Coordinates say where a point is on the grid. A coordinate plane is a grid that contains the x-axis and the y-axis. After we graph our coordinates on the coordinate plane, we connect our 2 points with the line segment. And here's our graph with our 2 points or coordinates and our line segment. Now it wants us to find the slope of the line segment. And up to here on the top, you can see we could use rise over run or the slope formula.
What is the slope and how do you find the slope?
The slope is how steep the straight line is. To find the slope of a line segment, you can either use rise over run or the slope formula. In this problem, I will show you using rise over run, but I have another one I'll show you using the slope formula. So you count up from your bottom point and you go up. Or over here, I have the coordinates worked out in the slope formula. You can go up 4 and over 2, or 5 minus 1 is 4 and 5 minus 3 is 2, which gives us 4 halves. When you reduce it, it gives us our slope, which is 2. All right, again, we have 2 coordinates that we need to plot, and it wants us to find the slope of the line segment. So let's plot our points. All right, and here's our line. If you notice that our line is vertical, so our line segment slope is undefined.
Why is the slope undefined?
Well, since it is a vertical line, it has an undefined slope because all the points on the line has the same x coordinate. If you were to use the slope formula, you'd end up with a 0 in the denominator, which the denominator is the bottom number in a fraction, which also tells us that the slope is undefined. All right, now we got a bunch of negative coordinates. Let's find the slope for this one. And for this one, we're going to do the slope formula. So we need to have our graph and point. There's our points and our line segment.
How do you know which x and y to use for the slope formula?
Well, in the coordinates given, the first number is the x and the second number is y. So for point U, x is -1 and y is -4. Since point U is the first point or coordinates, the x and y will be 1. And for point V, it's going to be 2. So we'll plug in the numbers into our slope formula and solve. So we have -13 minus -4 and a -4 minus -1, which gives us -9 and -3, which gives us the slope of 3.
So here we are given 3 equations of a parabola, or of parabolas, that we have to graph on the coordinate plane. And remember that a parabola is that curved U-looking shape.
How do you know that they are not just straight lines?
Well, just by looking at the equation, we know that they do not make straight lines. So a straight line is a product of a linear equation, which is written in the form of y equals mx plus b. And we looked at that in the last few graphs, right? The y equals mx plus b, that ought to be drilled in our head. Well, here at the top of our table, you do not see any mx anywhere, right?
No.
So we know we do not have a straight line. So here in our table, we took random numbers for x. In my case, I used -10 and I went all the way to +10. So in column 2, if you need to, only do one column at a time. Do not get overwhelmed with this because it really is easy peasy. So f of x, remember whenever we use f of x, because that's all that parentheses right there means, is y equals. So if you need to, think y equals x squared. What is x squared? X squared is, when any number times itself, right? So if you had 5 squared, it's 5 times 5. So in this problem, take your value of x and put it in that equation, and that's where you get that second column. And we're going to do the same for the third and fourth column. So g of x, so that's y equals x squared plus 7. So we'll substitute x in that problem. And then in the last problem equation, we're going to substitute our x values and square it, but then we're going to subtract 7. So we'll go to our coordinate plane. And here you will see that our graph, the parabolas get narrower and wider depending on if we added 7 or subtracted 7 from our original problem. So now we're going to see that I added a black line to this graph because visually I like seeing that x-axis marked where it goes through 0 on our graph. And when you see here, it goes through the point of origin, which is 0, 0. And when looking at this graph, you will see 2 of the 4 sections or quadrants. Here you see 2 quadrants.
Crystal.
And this is how you label. What's that, Laura?
What exactly is a quadrant?
Oh, okay. So a quadrant is a section of our coordinate plane. So our x-axis divides our coordinate plane into the 4 parts, our x and y-axis. So we'll start at the top right corner, and that's quadrant 1. Then you're going to move to the left. We're going counterclockwise in this problem, and that's quadrant 2. Then we go down, and that's quadrant 3. And to the right, we have quadrant 4.
For the next problem, we will be looking at perpendicular lines on a graph.
What does perpendicular mean?
I am so glad you asked because I have pictures to show you what perpendicular means, Crystal. Perpendicular means basically two lines meet at a 90-degree angle, so it'll look like a perfect L shape. So here's a perpendicular line right here. Boom, boom. See that perfect L 90-degree angle? There's one. There's another one. There's our L shape actually, but it also means another L shape. There's perpendicular lines throughout this whole thing. And there's Pac-Man, has a perpendicular line. So all we got to do is perpendicular line, perpendicular line, perpendicular line. They all meet at that 90-degree angle. And since our 360-degree angle, because that's what a perfect circle is split up into 4 places, 90 degrees, all around each side will be 90 degrees. It'll make basically a plus like this. And each side will have our 90-degree angle. Okay, so the first equation is given to us, -3/4 x plus 5. So what we're going to want to do first is find the negative reciprocal of the equation.
What
Yes.
is a negative reciprocal?
A negative reciprocal is, so let's say our slope is a over b. A negative reciprocal of that would be we'd flip it and then we'd add a negative or take the negative away. Easy, in a way to easily say it. So if our slope over here is a over b, we'd flip it, we'd get b over a, and we'd add a negative. If this had a negative, we'd flip it and we'd take the negative away. Basically, how we know that we have correctly found the negative reciprocal is if we multiply the slopes by each other or numbers or whatever by each other, we want to have -1. Okay, so for our problem, we are now finding the perpendicular line to this number, and it has given us coordinates. So what do we do first? We find the negative reciprocal of the slope. There it is. I just kept the +5. I could have done +b. I just did it to kind of keep my head where I needed to be. So now we're going to plug in our coordinates. But Kat, where are our coordinates? Well, here they are, x and y, x and y. Oh, look over here, x and y. And there's our m, so all we got to do is plug that in, and there you go. Simple algebra. So we plug our numbers in, we get -1 equals 4/3 times 6 plus b. So now we just solve for b, and we get b equals -9. Now our equation is y equals 4/3 x minus 9. And here's our graph. Kat, that is not a perpendicular line. What are you thinking? You're so silly. Well, as it turns out, Excel and Kat are not very good friends right now because scaling makes making a perfect perpendicular graph on Excel very difficult. So I apologize that it is not a perfect L shape, but we're just going to close our eyes and pretend that it is. Just close your eyes for a minute. Oh, I see an L when I close my eyes. Imagine that. Okay, now next. Okay, so for our next one, if you see, this is what it has given us, and this is not in our slope-intercept form, and we are definitely going to have to put it into slope-intercept form.
So, Kat, why do we even need to put it in slope-intercept form?
Slope-intercept form makes things easier, makes things flow. We know what our slope is, we know what our intercept is, but right here, we don't know what anything is. We don't know what our slope is. So how are we going to possibly find the negative reciprocal? How are we going to graph this? How are we going to get coordinates out of this? We're not. We've got to put in that slope-intercept form because it is a linear equation that we have here. So when we convert it to our slope-intercept form, we get y equals -9/2 x minus 5/2. And then, so then we would do our negative reciprocal, and since this one has a negative, remember, we're taking it away. And so we get 2/9x plus b. And then we plug in our coordinates as we did before, and we get b equals -3. And then again, we're going to see how Excel is not Kat's friend, and is not going to be a perfect L. So I apologize, but we're just going to close our eyes and pretend once again that Kat has made a perfect L and has just wowed us all. Okay, so close your eyes for just a second. Perfect L. There she is. We see her when we close our eyes. Okay, Crystal will finish it up with our last problem here.
Crystal, on our next problem, it states that the radius is 9. What exactly is a radius?
Okay, so the radius of a circle is the distance from the point of origin, or that center point where x and y are both 0. So our coordinate would be 0, 0, So our radius is how far from the center, that point of origin, does our circle extend. So in this case, it says that our radius is 9. So that means we can go out the x-axis to the right, and it'll go all the way to 9. We can go up and on our y-axis, and it'll be positive 9. Or we can go to the left, and it'd be negative 9. Or we can go down, and it'll be negative 9 also. So our radius tells you from 0, 0, how far out do we go in all directions. So here we have placed our points on the graph, and you will see negative 9, 0, 0, 9, 9, 0. That's positive 9, 0 this time. And then on the bottom, you're going to see 0, negative 9. But then we made a table. And don't worry about that third column just yet. Go ahead and make your table with just 2 columns, X and Y. And we're going to put these points. So for every point, you're going to see an X and Y in that table. So there you go. Well then, after we created our table and plotted our points, we're going to go ahead and draw that circle through all these points. And here you're going to see that the center of that circle is 0, 0, correct? You can see that. Now it says we have to draw a tangent line.
Crystal, what's a tangent line exactly?
Well, our tangent line barely skims our circle at the radius. And here on problem A, it's saying we're going to have our tangent line running through on a horizontal line at 0, negative 9. So, excuse me. So now we have to find the equation of our tangent line. And in order to do that, we have to know our slope. Well, let me give you a hint. The slope of a horizontal line is 0. Remember, we have to have a rise over a run, and there is no rise. Do you see a rise? I don't see a rise. So our slope of a horizontal line is always 0. And our tangent line is at 0, negative 9. So now we need to find our equation, and we're going to use the formula y minus y1 equals m, but remember that's our slope, times x minus x1. And as we go to the next part, we're going to go ahead and substitute. And remember, we're using our values for x1 and y1 is that original point that our problem gave us of 0, negative 9. We substitute in here y minus negative 9, which when we're looking at that side, we know is the same when you subtract a negative, that's the same as saying y plus 9 equals 0 times x minus 0. So we have to distribute that slope of 0, and anything times 0 is 0, correct? So here we're going to look at the next part where it's going to tell us that y is equal to 0x minus 9. So how did we get that? Well, remember, we need y by itself. So where we originally had y minus negative 9, which is the same as y plus 9, we have to take away 9 from the left side of that equation. So when we subtract 9, we have to bring it to the other side and subtract 9 over there also, which gives us y equals 0x minus 9. You can also do y equals negative 9 because 0 times x is 0. But here we're going to go ahead and place that in our original table. We're going to add another column. And when you substitute all our values of x, so remember we're going to go ahead and substitute our values of x. Well, 0 times anything is 0. So now you're left with y is equal to negative 9 always. So go back to our graph and we see that for every x value, it's negative 9. So then problem B wants to know, well, what if with our radius 9 and we look at the point, our tangent line is at 0, 9. So what will our y values be then? Well, our y values, it's going to be the opposite of what our first problem is, correct? Because instead of 0x minus 9, it's going to be 0x plus 9. So that gives us our answer to problem B of our tangent line at 0, 9. Do y'all notice anything about these lines?
They're parallel.
Yep.
They're parallel. So parallel lines never meet. You know, it's like railroad tracks. They're never going to come in contact with each other. So this is chapter 8. And thank you for visiting with us. And I hope we shared a little light and made this a little bit easier. Thank you.
Thank you. Bye.
Bye.